storage. Coming to some of the basic concepts. So in general, if you're going to see that the maximum size of a memory that can be used in any computer is determined by the addressing scheme. For example, a 16-bit computer that generates 16-bit addresses is capable of addressing up to 2 to the power of 16 is equal to 64 kilobytes of memory locations. Similarly, a machine whose instruction generates 32-bit address can utilize a memory that contains up to 2 to the power of 32, that is equal to 4 gigabytes of memory locations. Whereas a machine with 40-bit address can access up to 2 to the power of 40, that is 1 terabyte locations. The number of locations represents the size of the address space of the computer. Most modern computers are byte addressable. The figure shows the possible address assignments for a byte addressable of a 32-bit computer. The big endian arrangement is used in the 68,000 processor. That's nothing but 68000 processor. The little endian arrangement is used in the Intel processors. The ARM architecture can be configured to use either arrangements. As far as the memory structure is concerned, there is no substantial difference between the two schemes as a big endian or little endian arrangement. In generally, the memory is usually designed to store and retrieve data in word length quantities. In fact, the number of bits actually stored or retrieved in one memory access is the most common definition of the word length of a computer. For example, consider an example, a byte addressable computer whose instruction generates a 32-bit address. When a 32-bit address is sent from the processor to the memory unit, the higher order 32-bit determine which word will be accessed. If a byte quantity is specified, the lower order 2-bit of the address specifies which byte location is going to be involved. Example, in a read operation, other bytes may be fetched from the memory, but they are ignored by the processor. If the byte operation is going to be a write operation, however, the control circuitry of the memory must ensure that the content of the bytes of the same word are not changed. Modern implementation of computer memory are rather complex and difficult to understand on the first encounter. To simplify our introduction to the memory structure, here we will present a traditional architecture. Here, from the system point of view, we can view the memory unit as a black box. Data transfer between the memory and the processor takes place through the use of two processor registers, usually called as MAR, that is nothing but memory address register, and MDR, that is nothing but memory data register. So if MAR is a k-byte address or a k-bit address bus, a k-bit address long, and MDR is going to be an n-bit long, then the memory unit may contain up to 2 to the power of k address locations, whereas the word length is equal to n bits. Okay. During a memory cycle, n bits of data are transferred between the memory and the processor. This transfer takes place over the processor bus, which has k address lines and n data lines. The bus also includes the control line over here, which consisting of read or write control or memory function completed, etc., for coordinating the data transfer. Other control lines may be added to indicate the number of bytes to be transferred. The connection between the processor and the memories are shown in the particular structure in this architecture. So the memory address register, which is going to be connected through address bus to the memory, whereas the memory data register, which is going to be connected to the data bus to the memory, and the control line which interacts or interfaces the processor and the memory. Here, actually, the processor reads data from the memory by loading the address of the required memory location into the MAR, which is going to be get requested from the memory to the processor, and uh, the setting of a read or write line which is going to be get indicated 1. For example, read slash write bar is going to be 1. Then the memory respond by placing the data from the address location onto the data line and confirms this action by asserting the MFC signal. MFC is nothing but memory function complete signal. Upon receipt of the memory function complete signal, the processor loads the data on the data line into the MDR register. The processor writes data into the memory location by loading the address of this location into memory address register and loading the data into the memory data register. It indicates that a write operation is involved by setting read slash write bar as 0. If the read or write operation involves consecutive address locations in the main memory, then a block transfer operation can be performed in which the only address sent to the memory is the one that indicates the first location. Okay, so memory access can be synchronized using a clock, or they can be controlled using a special signal that transfers on the bus using the bus signaling scheme, as well as a memory read write operations are controlled as input and output bus transfer respectively. Okay, a useful measure of the speed of memory unit is the time that elapses between the initiation of an operation and the completion of the operation. Let us see the basic concepts which is going to be useful for this to understand the memory. Measure of a speed of a memory. So generally we are going to see about memory access time and memory cycle time. What actually the memory access time? The time between the read and the MFC signal. Actually, if you're going to see about that, a memory unit is the time that elapses between the initiation of an operation and the completion of that operation. This is referred to as memory access time. Memory access time. And another important measure is the memory access time, cycle time, which is the minimum time delay which is required between the initiation of two successive operations. For example, the time between two successive read operations. The cycle time is usually slightly longer than the access time, depending upon the implementation details of the memory unit. Okay, so a memory unit is called a random access memory, RAM. If any location can be accessed for a read or write operation in some fixed amount of time that is independent of the location's address. This distinguishes such memory units for serial or partly serial or access storage devices such as magnetic disk and tapes. So this access time on this later device depends on the address or position of the data. So the basic technology for implementing the memory uses semiconductor integrated circuits. So the some of the basic facts that the internal structure and operations of such memories we will discuss. So in general, if you're going to see about that, some techniques are used to increase the effective speed and size of the memory also over here. So the process of a computer can usually the processor of a computer can be usually process instructions and data faster than they can be fetched from a reasonable priced memory unit. So the memory cycle time is a bottleneck in the system. One way to reduce the memory access time is to use a cache memory. So this is a small fast memory that is inserted between the large slower main memory and the processor. It holds the currently active segments of the program and their data. We will see about that particular cache memory and the virtual memory in detail about those things in the future, in the next classes. So coming to this virtual memory, the virtual memory is another important concept which related to memory organization. We have assumed that the addresses generated by the processor directly specifies a physical location in the memory. This may not be always be a case for reason that will become apparent. For example, data may be stored in physical memory locations that have addresses different from those specified by the program. So the main memory control circuitry translates the address specified by the program into an address that can be used to access the physical memory. In such cases, a address generated by the processor is referred to as a virtual or logical address. The virtual address space is mapped onto the physical memory where data are actually stored. The mapping function is implemented by a special memory control unit, often called as memory management unit. This mapping function can be changed during program execution according to the system requirement. In general, if you're going to see about that, the virtual memory is used to increase the apparent size of the physical memory. Data are addressed in a virtual address space that can be or as large as the addressing capability of the processor. But at any given time, only the active portion of the space is mapped onto locations in the physical memory. The remaining virtual addresses are mapped onto the bulk storage devices used, which are usually magnetic disks. As the active portion of the virtual address space changes during the program execution, so the memory management unit changes the mapping function and transfers data between the disk and the memory. Thus, during every memory cycle, an address processing mechanism determines whether the address information is in the physical memory unit. If it is, then the proper word is accessed and execution processed. If it is not, a page of word containing the desired word is transformed from the disk to memory. Okay, so this displays some pages in the memory that is currently inactive. So because of this time required to move pages between the disk and the memory, there is a speed degradation if pages are moved frequently. By choosing which page to replace in the memory, however, they may be reasonable by long period when the probability is high that the word accessed by the processor are going to be in the physical memory unit. Okay, so we will see about the next slide with the memory interleaving. This is a technique which divides a memory system into number of memory modules, which arranges the address so that the successive word in the address space are going to be placed in the different module. When requests from a memory access involved consecutive addresses, the access will be to the different module. Since parallel access of those modules is possible, the average rate of fetching word from the main memory can be increased. Let us see about the semiconductor RAM memories, the next topic